Welcome to Spring LIB.
Okay, for this problem, there is a bungee jumper. 55-kilogram bungee jumper is leaping from a bridge, and she's tied to a bungee cord. The unstretched length is 12 meters long when it is unstretched. So we'll just sketch the situation here. So this is the bridge level, and the bungee jumper is, attached to the rope. So, and this is attached to the rope here, and we assume the center of mass is at this location right here. So we'll say this is the location of the bridge. Now, the length of the rope is 12 meters. So when she's going to jump, right in the middle of the jump, what is going to happen is that she's going to reach this location, okay, at this location. And at this location, the rope at this point just starts to get stretched, which means that this length is just 12 meters. And then she's going to reach the ground level, this is the ground level. So what happens is that the rope starts to get stretched from this point. So she reaches at this location. And it says that she falls a total distance of 31 meters. So this is 31 meters, which means the rope has actually stretched 19 meters because 19 plus 12 is 31. So that's a problem. So if you look at this whole problem here, in fact, the mechanical energy is conserved because conservative force is acting on the system. Because the conservative forces are the spring forces and the gravitational forces. So the mechanical energy is conserved of the jumper. So now we are going to define a level. So this is the ground level. We'll have y1 is equals to 0. This is the level y2. With this point, the rope starts to get stretched. And this is the level y3 at this location. At this location y3, the height is 31 meters. So what we are going to do is that we are going to equate the energies at the location 1. So total energy at 1 should be equals to total energy at 3 by the law of conservation of energy. So total energy at 1 at this point, when she is at the lowest point, the velocity of the jumper is 0. And then at this point, we have no kinetic energy, we have no GPE, but at this point, the only energy in the system is the elastic potential energy because the rope is stretched. Okay, at the top level, at this point, again, there is only GPE and there is no elastic potential energy because the rope is not stretched, and there is no kinetic energy because she's starting from rest. So if we can equate the energies at 1 and 3, so total energy at 1 is just mg y3. That should be equals to total energy at 1, which is the ground level, which is equals to half k, the stretch, whatever is the stretch. So let's take the stretch to be x here. So x squared. So in this case, we can equate these two equations. So the problem says to find the value of k. So the value of k here is equals to 2 mg y3 divided by x squared. All right, so we just plug in the values here. So we have 2 times 55 times 9.8 divided by 19 squared. That gives you around 93 newtons per meter, which is the force constant of the spring on solving this. All right, for the part B of the problem, the question is that calculate the maximum acceleration she experiences. Now the question is to calculate the maximum acceleration. Now the maximum acceleration occurs at the location of the maximum force. The maximum acceleration is at the maximum force because force is equal to mass times acceleration. Now what is the location at which the maximum force, because the force changes according to the equation F is equals to negative kx. So therefore, the maximum force which occurs when the bungee cord has its maximum stretch. So F max occurs when x is max. So therefore, at that location, you will have the F of the cord acting upwards, and at this location, the force diagram would be mg, the force of gravity acting downwards. So that is the location of the maximum force, where the force is maximum at the location where x is maximum. So at that point, I've drawn the force diagram, two forces acting on the cord, F cord and Fmg. So we apply Newton's law for that. Net force at that point is equals to ma, and the net force at that point is equals to F cord minus mg. So we have F cord minus mg is equals to ma. So we can find out the value of the F cord. So F cord is equals to kx at that location minus mg is equals to ma. So acceleration on rearranging will be equals to kx minus mg divided by m. So that is equals to kx by m minus m. And if we just plug in the values there, so we'll get K is 92.57 approximately from the previous problem. The maximum stretch was 19 divided by 55 minus 9.8, and that should give you around 22 meter per second squared as the answer to the